We are going to start again. Please go back to your seats. Yeah, please. Thanks. We're going to start again. The next presentation will be given by Kate Murray, Jérôme Martinez, and Dave Rice. Please.
Hi, everybody. I'm Kate Murray from the Library of Congress in FAGI, and I'm just here to give a brief introduction before I really turn it over to the stars of the show about our work with FFmpeg, which FAGI has some support for, to continue our support for captions and timecode. And I'm also going to hype my swag, so we have FAGI bookmarks, so I hope everyone takes a FAGI bookmark. They're out there on the counter. Dave and Jerome will cover the nitty-gritty, but just as some background, this work was grounded in a FAGI project immediately before the pandemic to evaluate FFE1 and Matroska for use by FAGI members. And Charles Hosale and I went to visit Blake McDowell at the National Museum of African American History and Culture the day before lockdown, back in 2020, and we did some testing, and what we realized that while the structures for timecode and caption support within FFE1 and Matroska were established or well on their way, there was some gaps in the tool set in FFmpeg to support complex timecode and captions, especially with TTML, which is a major component of the RDD48 MXF application. This was a roadblock specifically at the Library of Congress for expanded use and adoption of FFE1, so FAGI, which is led by the Library of Congress, wanted to improve the tooling on behalf of the wider community and eliminate this barrier. So we contracted with Dave and Jerome to work with the FFmpeg community to research and make the changes over the last year or so. Much of this interest at the Library of Congress revolved around the library's recommended format statement, or RFS, which until just a few weeks ago included FFE1 and Matroska as an acceptable format for content without captions or timecode. But there was very strong interest from some communities, especially but not limited to public broadcasters in the US, to have the Library of Congress accept FFE1 and Matroska. So the moving image content team for the recommended format statement wanted to be able to move FFE1 and Matroska from an acceptable format to a preferred format. I won't go into too much detail about the RFS here and how we make those decisions, but we have an evaluation matrix that we use for all formats, which includes both global community factors and local institutional factors to give us a framework for discussion and decisions. We have a sample matrix available on our website so that others can tweak these for their own institutional needs. And most importantly, acceptable doesn't mean not as good as preferred. In some cases, it's not an issue with the format or its capabilities, but rather the Library of Congress's ability to manage the format, as was sort of the case with FFE1 and Matroska. But this work with FFmpeg allowed us to improve the tooling and make the changes in status for FFE1 and Matroska, and you'll hear more about this in an upcoming blog post on the Signal, and which we'll share with the No Time to Wait community. Thanks to the great work of, this is just my shout out page, the great work of Dave and Jerome, as well as the Library of Congress home team, especially Laura Davis, Rachel Curtis, Morgan Morrell, Charles Hosale, Andrea Lee, Mike Michon, and more. And I'm going to turn it over to Dave and Jerome.
Where's my slide? Oh, this isn't the version of you editing it.
Sorry.
I'll just improvise until then. So I just thought, I don't know, I'm very happy that No Time to Wait is back in Prague this year, because it was, I think, in 2015 that the Internet Engineering Task Force was here, and Jerome and Tessa Fallon came here to present and defend a proposal for a working group of the Internet Engineering Task Force to standardize FFE1 and Matroska. And that kind of led into the No Time to Wait conference that happened the following year in Berlin. With this work that Kate's mentioning, there's always these little incremental efforts side by side in the standardization of the format and then the implementation of the format. So, slides are back. So I think this happened in 2021. The IETF, the Cellular Working Group, finished their work on the FFE1 specification. So it's released as this RFC. So this is a lossless video encoding. Many people in this room have been involved in its history, development, advocacy, and now it is sort of officially standardized with the IETF. So that fact kind of helps encourage more of the implementations to occur. With Matroska, oh, and by the way, these are the documents of the Cellular Working Group. So FLAC is involved. A bunch of these documents are related to Matroska. And then at the bottom are the standards for EBML, which is a binary XML format that Matroska is based on, and FFE1. Those two are the publications already. And then just during this week, I had to update this because Matroska is in, that specification is in its final stages. It went through a big review and a voting process by the Internet Engineering Task Force, the Internet Engineering Steering Group. And a bunch of nitpicks come back and last questions. Those all got finalized, so now it's been moved over to the RFC editor at the IETF, basically just to work on the formatting and the presentation of the standard. So the current status, I think, is the RFC editor has acknowledged that we've responded to their latest questions, and we're waiting for them to proceed through their editorial work and possibly come back to us. So another example I wanted to make about like the incrementational development of the specification and well, the development of the standard versus the implementations of that standard is the work on the CRC element of EBML, which is part of Matroska. So in EBML, once we had standardized this, this aspect of the format that under each top-level element there could be a CRC, just a checksum that protects all the content of that element. So if you think of like a Matroska file as this like nested set of folders, the folders can contain checksums of the folders and documents inside it. This had been written, I think, back in 2004 or 5 in the EBML specification, but I had never seen it implemented. But once we had the specification written, then in FFmpeg, they implemented it and just turned it on by default. So pretty much any Matroska file you get coming out of it that isn't a live stream will have CRCs embedded into it. They realized this was like so little overhead in the encoding time that it was worth just turning it on by default. So one of the things we're working on getting implemented is getting timecode into Matroska. So we ended up working on this document, like an intermediate document just called media timecode that could document any type of timecode track. So at the top you see timecode tracks that are based on presenting an initial value and some incrementation data on how those timecodes should increment for continuous timecode tracks. But another type of common timecode track is with every value independently stored. And that's where you could have non-continuous timecode. So the aspect of the, oh, I missed that slide. So there's an aspect of the specification called the block addition. And basically all the encoded audiovisual data is stored in these elements called blocks. And the block addition just lets you map on tags onto that. So it's used for dynamic HDR data, and it also can be used for timecode values. Basically like any tag you would want to associate to a particular audio, video, or subtitle frame. So I can ask Jérôme some questions.
Yeah, no. We can work with this intermediate format, timecode format. We can extract, for example, all the timecodes values from the MXF. We can edit, so if we need to curate the timecode, we can do it. And then we are developing for the Library of Congress an update of FFmpeg supporting this XML as input, and in order to put in the Matroska container all the timecode. So step by step, we reduce the gap between MXF and Matroska. So as Kate said, currently, Matroska FFE1 is recommended when there is no timecode, no captions, and we work on having Matroska supporting timecode and caption the same way that it is supported in MXF in order to have a fully lossless conversion of the content from MXF to Matroska, including the timecode and the captions.
Yeah, it already had been the case for a while that you could do a lossless conversion of the audiovisual data of, say, JPEG 2000 and MXF to FFV1 and Matroska and vice versa, but that wasn't the case for all the data streams like timecode and some of the captions. So we've been tediously nitpicking through. This command at the bottom is from a patch Jérôme's written for FFmpeg to basically take timecode out of this intermediate document I was showing before and attaching that into a Matroska document. So you could map timecode values into a video track, in the same way you would like stream copy using FFmpeg from one container to another.
Currently, it is in our own build of FFmpeg, but we are cleaning up the code, and we will send the code to the FFmpeg team in order to have a review from them and to be integrated in the master branch of FFmpeg. So for the moment, it is easier for us to have a demo with our own build because we can show that how it works. But definitely, the idea is to have everything in FFmpeg directly.
Oh, sorry. I will say, Jérôme, that we have taken off the disclaimer on the recommended format statement that previously we had said for collections without timecoder captions, we have taken off that disclaimer thanks to this. So yeah, so that's a good thing. So, that's it, folks. So thank you.
Thank you very much. I thought there was a question, but there wasn't. Other questions?
Hello to lady. You don't feel a little bit doubled because part of things standardized by AITF and part in SMPTE. Duality, how you live with this duality?
Life is duality. But no, I will say that FAGI a year or two ago supported a mapping of FFV1 into MXF in RDD 48, Amendment 1 in SMPTE. And I don't feel any tension, and I think most folks at the library also don't feel any tension, the fact that MXF is standardized through SMPTE and FFV1 and Matroska through IETF. I personally find the standardization process in IETF more transparent and accessible than I do in the SMPTE standard, and I'm a member of the SMPTE standards community, but I think it's a lot easier and more transparent for anyone in the community to follow along in IETF than it is in SMPTE. So I find both standards processes to be as complete and as, what's the word I'm looking for, to a great level of detail. So yeah, I don't see any stress there about supporting both communities. Some folks will use SMPTE, some folks will use MXF, some folks will use FFV1 and Matroska. Our goal is to be able to provide the maximum amount of capabilities in either format, so no matter which one you choose, you have the same, you could have the same content in both. So.
I can add that I think traditionally a lot more audiovisual formats had been standardized through SMPTE, but gradually over the last few years, like IETF was doing more and more audiovisual standardization, just because audiovisual data was more and more a component of the internet. So like they standardized the Opus audio codec, which is often used sort of behind the scenes for communicating in Skype and Zoom and other formats. I don't know, but just like the internet is containing more and more of our data in every single form, so it's sort of less tied to like the exclusive like broadcast community that kind of started with that where SMPTE started as a default place for standardizing those formats. Cool.
Thank you. continue with a presentation of Jérôme.
Yeah, I stay on stage. So hello, some repetition maybe to compare to people who were in the workshop yesterday, because it was a last minute workshop. Sorry, but for the others I will present a bit MediaConch and MediaInfo, also the new features in both products. I present both together because they are linked together, and one is more focused on the reporting, and one is more focused on the implementation and policy checker. So the goal of MediaConch is to be an implementation checker and policy checker. The difference between implementation and policy is implementation we compare to the specification. So it is not you, it is compared to the standards. And the policy checker, it is something you create, the limitation compared to the standard, what you accept or don't accept in your repository. And inside MediaConch, there is a reporting part, it is MediaInfo. MediaConch is based on MediaInfo, so any format supported by MediaInfo is available for the policy checker. For the implementation checker, it is a bit different because MediaConch started in 2015 with some European Union funding, and it was initially focused on open source formats, so Matroska, NTTW, and PCM. So for the implementation checker, it is a long process. It is a big thing to do. We need to select a couple of formats we focus on. So currently, MediaConch supports the implementation checker mostly for Matroska and FFV1, plus some PCM tests. We want to expand it. But yeah, we are looking for sponsorship for expanding it. For the policy checker, it is easier because we just need to rely on MediaInfo, the analysis for this kind of policy checker, seeing how the count of channels, the frame rate, and so on. It is easier, so we don't need so much sponsorship for implementing that in MediaConch. For some history, the name of the European Union funding for that, it was Preforma, and Preforma was focusing on for the video on Matroska and FFV1, but there was other companies selected for PDF and TIFF conformance checker. And Preforma was also the start of the IETF working group we just talked a few minutes ago. And it was also the start of No Time to Wait conferences. So the Preforma project sponsored No Time to Wait 1 and 2, if I remember well. And then other sponsors decided to keep going. The Preforma project stopped. And we still have some No Time to Wait events because archives decided that it is worth it to sponsor the No Time to Wait conference. So this year in the MediaConch, we have different new features. In the past, it was only error or pass. Now we have some different level of logging, like warning or information. It is used, for example, that people want to warn the operator that a policy is acceptable today, but next year it will not be acceptable. So there will be a limitation. So it is not an error for the policy of the entity now, but there is already a warning which will become maybe an error in the next policy next year. We also have a full online version of MediaConch now, so we don't need to be on the desktop. We can just launch a JavaScript version. It is used by some entities to check before an upload by internet that the file is conforming to some specifications of some policies from the entity. We also have a better support of several audio tracks. At the beginning, archives were interested only by one video and audio, and one audio, because it was the classic usage. But some other users were interested in different files with more audio tracks. We have also now a USAC implementation checker. It was sponsored by Fraunhofer, who was interested to have a conformance checker for everyone, so not only in tools like Baton and so on. So anyone developing a USAC encoder can check with MediaConch that the file is conform to the specification. For some people interested to have a quick check in their repository, we've also added an option for parsing only the header of the file. So we cannot test everything in the video stream, for example, but some people just need to know that it is an MP4 with FFV1, for example, and we scan quickly all the repository for seeing if the repository contains only that or some other things. We also added a lot of different features in MediaInfo only. I will do a focus on the MPEG 7 output, for example. It is only in MediaInfo. It is an export, so it is only reporting. We have for a long time MPEG 7 output, so not the classic MediaInfo output, but also the possibility to export to other format, output format. MPEG set is a way to present different metadata. So for the needs of the Bibliothèque Nationale de France, the French National Library, we developed an extension of MPEG 7 because MPEG 7 is from ISO and it is a bit frozen. There is no more any working group expanding it, but we have new formats, so and we have new needs, and in that case, when the standard is frozen, we need to decide if we leave this format, but for which one, or we just decide to expand it. So we added some different modes, relaxed and extended, and these modes are not standard, they are not the standard, but they fill a need. So the relaxing mode is if it is not so important, the feature is not so important, we try to be standard. But if there is, for example, 2 audio tracks, it is not compatible with MPEG 7 output, so we add another track, it is no more compatible, but so it is an extension of MPEG 7 supporting 2 audio tracks or 1 caption track, for example. We need to display captions now today, and it is not in MPEG 7, so we just extend it. So we try to keep the way it is defined in MPEG 7, but with our extension. We add also a new audio presentation IDs. So we have new format, and it is not listed in MPEG 7. So we add new names and new terms IDs. We also add more public identifiers and so on. So when there is a need, we try to be compatible with other standards, but sometimes we need to extend it, and we do it without problem. We also added ISO support, currently focused on DVD video. It was also sponsored by Bibliothèque Nationale de France and with some help of New York Public Library. We also added new HDR formats, so it is more modern. We have new HDR format from SMPTE or from China. HDR Vivid, for example, is the Chinese version of HDR. The world is still not able to agree on one format, so we need to support another format. We did a focus on the timecode in Matroska, so for the Library of Congress, but also in AVC and HEVC, there is some timecodes. It is not supported in FFmpeg, for example, but we support in MediaInfo. As said previously, we can extract all timecode from a file in XML format. We support very weird files. I will do some discourse about aptX100. It is a very technical name, and it is actually some cinema details. It is something we didn't implement in MediaInfo. We are the main developer of MediaInfo, but anyone interested in developing a format can do it. So one day there was a guy who sent a public a push request and saying that there is this kind of format, cinema DTS. I was not aware that there is a couple of CDs in cinema with DTS, but it is not the classic DTS stream you get usually. There is maybe a couple of hundreds of movies with this CD, with DTS CD. And we have no budget for developing that, but when a fan community is interested about that, they can provide a kind of support and implement themselves. And for us, it was very surprising to see that there is different commercial names, like these ones, and it is actually technically the same, and there is small differences, and without being a fan, we are not able to know the difference. Because with DTS, in the past, it was maybe 20 or 20 years ago, the way to detect the commercial name is a bit crazy. It is, so here we have, for example, the channel count in the file, and actually we need to see how it is exactly. If there is a channel count of 2, actually it is 4 because there is some matrixed channels. But also, if the value is 5, we need to check the serial number of the file written in the file, because sometimes there is a matrix over channels, sometimes there is not, and sometimes it is linked to DTS 70 millimeter, sometimes for linked to 35 millimeter movies, and the only way to know that what is the commercial name or what is exactly inside the content is to check the serial number. And without being a fan, it is difficult to know that. And so, yeah, we don't have the resources to do that, but when you have a fan community who is passionate about that, they try to get any CD, and they want to have a good metadata about that. And they send a patch for that. So it is not just us, it is you. If you know, if you have a knowledge about the format, you can develop also yourself a media info patch and send to it. We merge it in our source. We added also in media info more features about N19, STL, and WebVTT. We also support some very modern 3D audio in MXF, so SADM. So this is different development with format from the past or very new format. We can support any file format, modern or past. But media info is not only about software. We need also to have some documentation. So for us, it is difficult to maintain a documentation because usually sponsors want a feature only, and we try to be as cheap as possible. So we always say that the documentation is optional. But if you need documentation, we can also do it. So Bibliothèque nationale de France wanted more information about the media info fields. So now we have a version, we have a support page listing all the media info fields, and with a small description of each field, so it may help you to understand what is the meaning of each field. And we have also mapping to the MPEG set output or the EBU core output or the BBU core output, not only the media info output. So if you want to see the mapping between different output formats, you go on the media info web page, and there is in the support there is this this kind of information now. For next year, we have some commitment for some sponsorship for expanding MediaConch for the comparison operation between properties. Currently, we can just check, the channel count of the specific track is 2, for example, but we cannot compare the channel count between two tracks. We will be able to have that next year. We also are implementing ADM, audio data model. It is another audio 3D audio format. And there will be a full implementation shaker because there is a sponsor interested in that. We are also working a bit on MXF, an MXF implementation shaker. We don't have a big sponsorship for that, so it is only partial on some specific value, which are a big interest for a sponsor. We also work on the timecode discontinuities in MXF and Matroska in order to be able to see where are the timecode discontinuities in the file. We also plan to parse the VBI in MXF. So usually in most tools like FFmpeg and so on, the VBI is just opaque data, so it is not parsed. So and in MediaInfo we will catch the VATC timecodes and the line 21 captions in order to show in MediaInfo that it is present. So this is the kind of development we are working on, but actually it is done because we have some sponsorship. So actually, what is the future of MediaConch and MediaInfo? It depends on you. It depends on your needs. So just say what are your needs, and we can see what we can do for that. And we are not the only developer. If you want to develop, just send a patch. It is also possible. Yeah, that's all.
Thank you. Thank you, Jérôme. So, any questions? I have a question. So about perhaps very general question, how do you generally work with sponsors? Is it always for specific, like the implementation of specific new features?
No,
or
our business model is based on what is already developed is usually free of charge. It is open source, you can download and you can use it. And what we sell is some work, hours of work. So it is development of new features. Potential sponsors contact us saying, "Oh, I need that. Can you do that?" Yes, sometimes we can do that in MediaInfo or in or sometimes in FFmpeg. Sometimes we say, okay, it is not the goal of MediaInfo. We can adapt another tool, or we can create a new tool if it is a very specific need. We usually, yes, we sell the new features. So you are interested in a new feature, we find a way to develop it. We can also sell sometimes some maintenance contracts if you need bug fixes with a service level agreement. We sell a service level agreement also. So it is a more classic maintenance contract, but it is more rare. In the open source world, usually people don't care about the service level agreement. So some people want it, we do it too, but usually it is just paying for a feature.
any other questions?
In the one workshop we did, we talked about the case that we often have MP4 files, and we talked that maybe we could sponsor like an error detection of corrupted files, just limited to MP4, AAC, H264. And I wanted to, maybe other institutions would be interested, so
yeah,
maybe we could get together for a sponsorship.
But it is possible to share a sponsorship. For example, for the ISO support, the main sponsors was the Bibliothèque Nationale de France, but there was also a partial sponsorship from New York Public Library. So we try to find a way to invoice different entities for some feature when people are when different entities want to sponsor the same feature. So if you are interested in MP4 implementation checker for detecting any error in MP4, raise your hand and we talk together how we can find a way to have a common sponsorship. So I know, yes, you are interested, but maybe it will be too expensive for only one entity. So if other entities are interested in that, just get in touch and we see how we can have a common sponsorship.
If there are no more questions, then thank you, Jérôme. And we move on to a pre-recorded presentation by John Kunze and Donny Winston, getting running with ARK persistable identifiers. And John will be there also after the presentation for questions online.
Hello, my name is John Kunze. I'm a computer scientist who has been working with libraries, museums, archives, and data centers for the past 20 years. You may notice an unusual word, persistable, in this title instead of persistent. It's hard to talk about persistence when applied to identifiers because it's hard to forecast. If we check an identifier every day for 10 years, it might prove to have been persistent, at least in its first 10 years. It's easier to talk about an identifier as persistable. Anyway, more about that later. Why should we care about arcs? The average lifetime of a URL was once said to be 100 days. At the end of its life, a URL link breaks, usually giving you the dreaded 404 not found error that most of us have seen. That's irritating for most of us, but it's a minor disaster for memory organizations. So arcs can serve as robust links. The arc scheme is one of 5 so-called persistent identifier schemes, or PIDs. But there's been so much nonsense written about PIDs that we prefer the term persistable. Some of this is described in a Twitter thread called 10 Persistent Myths About Persistent Identifiers, available at the link using this example arc or the QR code next to it. Every link is potentially persistent, but strangely, some people think it becomes a PID when it acquires some superficial syntax differences, such as the arc colon in this example arc, or when you see the domain name doi.org at the start of a URL. Syntax is neither magic nor a guarantee. It's never more than a suggestion that you might find this link to be more stable than the 99% of URLs that are produced without a thought for preservation. So-called PIDs break regularly by the hundreds of thousands, which is a normal part of providing a preservation service. Committed service providers will even repair some of those links. So syntax doesn't make it persistent, but just possibly persistable. The nonsense was in full bloom in the late 1990s, but it polluted the debate about the 4 proposed PID schemes. That is why the Archival Resource Key, or ARC, identifier scheme was introduced in 2001. Here's what an ARC looks like. At first glance, it's a URL that carries this internal label. To the right, the 5-digit name assigning authority number, or NAN for short, identifies the organization that created the ARC. Further right, the part after the NAN names the thing that the ARC is assigned to. To the left, the host name makes the ARC actionable or something you can click on. It's also known as the resolver. ARCs are unusual among persistent identifiers in allowing organizations to run their own resolvers. The part starting with the ARC : is the core, globally unique identity. It doesn't depend on the host being available or on the future existence of the World Wide Web. In the previous example, you saw N2T.net, which is a global name-to-thing resolver. N2T is the main ARC resolver. So why doesn't it contain the letters ARK? Well, one goal of the ARC design was to break out of the silos and the walled gardens surrounding other identifier systems. So what got built was the name-to-thing resolver, or N2T. The domain name N2T.net is good for short citation strings, and true to its name, N2T also resolves hundreds of different identifier schemes. ARC organizations include a wide variety of memory institutions, nonprofits, for-profits, and government agencies. A few are listed on this slide. What are ARCs used for? Well, here are some examples. The heaviest user of ARCs is the largest genealogical research organization called Family Search International. Next is the archive of all the source files for mainstream published content. Technically, they have over 40 billion ARCs, but apparently only 100 million of them are interesting externally. The Internet Archive has been assigning ARCs to scanned books since 2008. The Smithsonian is rapidly expanding their use of ARCs with a target of 100 to 150 million. The French National Library was an early adopter, and here's a wonderful image depicting the biblical ARC. ARCs are also important for people, especially historical figures. For example, there's an ARC for the 19th century mathematician Ada Lovelace, and her ARC was assigned as part of the SNAC project, which is sort of like assigning orchids for dead people. Here's a brief case study for the Internet Archive's ARC implementation. Note their reserved NAN 13960. On the left is an example of a venerable library cataloging standard that has been digitized from paper and deposited in their text archive with an ARC. On the right is its metadata record, where you can see the ARC they assigned and its NAN inside the red rectangle. Note how different it is from the identifier field above it. In contrast, the ARC is opaque, which helps it age and travel well for external citation, even if it's awkward for backroom administrators. You can see a bunch of metadata above that, including 2 URN identifiers that came in with it. Best practice is to preserve all the identifiers you find. Here's an abbreviated history of PID schemes. Perls fully embraced the URL. Meanwhile, URNs, DOIs, and handles got confused for a while, saying that all URLs are bad, until they reversed that position and fully embraced the URL. Meanwhile, the inventor of the web said basically, just use URLs and manage them carefully. ARCs agreed and said, go ahead and use URLs, but embed a distinguishing label to suggest persistable, and include a globally unique identity separate from the domain name and from today's web protocols. Here's the grumpy old person view of PIDs. Looking at this table, the big block of no answers in the first 4 rows tells us that no PID scheme helps you with all of the major and most of the minor causes of broken links. So why even bother? Well, some of the PID schemes are free, so there will be more money to spend on the real work of preservation. This is a reminder for many of you that a core PID technique is indirect identifiers. which uses the web concept of redirects. First, here's normal direct access. A user clicks on a URL in the browser, which sends it to the web server appearing at the beginning of the URL, and a page is returned. With indirect access, the first server contacted says it doesn't know where the thing is, but returns a message that this other named server should have more information. This is web redirection, and it's like forwarding your mail to a new address. There could be a long chain of redirects all taking place behind the scenes and without the user being aware. If you buy into the idea that PIDs actually provide value, here are some details on things they might do for you. By an amazing coincidence, this table is quite flattering to ARCs. The bottom line is always about cost. No organization pays for the right to create ARCs, pearls, or URNs in unlimited numbers. In the real world, or maybe just the academic world, PIDs that publishers use play a key role. When tenure and promotion hang in the balance, DOIs are the publisher's solution, and they are seen as a kind of badge of academic legitimacy. Pearls are free and are common in the semantic web. URNs are useful if you're a national library naming static assets in a nation that subsidizes URNs. They have the unique advantage of having an internet standard behind them, even if it is frequently abused by creators of bogus URNs. Handles are popular in certain European projects and have a nicely replicated resolver infrastructure, also used by the DOI system, so they can be good if you can afford them. If you only have a couple dozen things to identify in a year, by all means consider going to zenodo.org and assigning their subsidized DOIs. In summary, ARCs are similar to DOIs. They're both persistable identifiers for accessing content and metadata, and ARCs are found in many of the places where you'll find DOIs. In contrast, ARCs come with no fees, no limits on how many you can create, and no metadata requirements. From the beginning, ARCs were designed to be decentralized and to identify any kind of thing, digital, physical, or abstract. Finally, it's important to note that there's no conflict using both ARCs and DOIs at the same time. This is quite common. For example, you'll find a mix of both at the Smithsonian, the British Library, and other national libraries. Here's a second use case, this one from the Smithsonian, whose NAN is 65665. I'm told by insiders that the technical challenge of ARCs was minor compared to getting over a dozen organizations within the Smithsonian to cooperate. You can see the Smithsonian NAN appearing at the beginning of each ARC here. You can also see the wide range of object types, biological specimens, paintings, photos, and sculpture. Note the long opaque names they've assigned, which were generated using the UUID software that's found on nearly every platform. These unique names are long, unfortunately, but easy to generate. Very briefly, here's another view of ARC syntax. It shows more detail than last time, but right now I just want to highlight the role of the NAN, or Name Assigning Authority Number. The NAN is a 5-digit number. NANs are opaque, which is good for longevity. But what if you want to know what's behind a NAN? In a browser's address bar, you can try truncating an ARC so that it stops after its NAN, as shown in the yellow highlighting. This is a stub ARC. If you hit enter, this lets you inspect the 12148 NAN. You can also try this with any other NANs. Or you could try backing off further so that the stub ends with just the ARK colon, and that will tell you about the ARC scheme. Finally, you can also replace that scheme with the name of any of the other 600 different schemes that NTT knows about, such as the protein data bank. All those NAN results are pulled from the main NAN registry, which is a plain text file that you can look at directly in your browser. You can use the QR code if you're interested. Here's what it looks like when you ask N2T to tell you what the NAN 12148 is. You get the record for the National Library of France, as well as when it was registered in 2005, and very importantly, where the N2T resolver should redirect incoming ARCs so that they get sent to the correct resolver. So the NAN has two purposes. It's a lookup key for the resolution reference point, and by defining a root of a global namespace, it isolates an organization's autonomy and responsibility for assignment of its ARCs. That way, without interfering with anyone else's assignments, the organization can determine its own policies regarding identifier form, uniqueness, and reuse, similar to how it can assign URLs under its domain name in any way that it wants. Here's a link to the form you can use to request a NAN for your organization. If you want to practice using it, just indicate in the final comments that you're filling it out as a training exercise. A great deal has been written about opaque identifiers, which age and travel well, but they can be confusing because they reveal nothing about themselves to the user. One approach is to soften the pain by making them shorter and so more citation friendly, but shorter IDs come at a cost. An emerging trend is to use an opaque base identifier with lucid or non-opaque extensions. That can be okay because extensions are more transient than the base thing itself. For example, image thumbnails are upgraded to be higher resolution over the years to keep up with evolving demand. This slide lists some tools for generating opaque IDs that I won't be getting into. Back to details of ARC syntax, the special characters / and period have reserved meanings in ARC suffixes, so that makes those characters effectively non-opaque. They help the recipient make inferences about one resource containing another, or one resource being a variant of another. In a non-ARC URL, you might guess at similar interpretations, but in ARC-based URLs, the guesswork is gone. If you use those reserved characters, you are formally declaring that these relationships exist. There's a natural parallelism between ARC suffixes and the popular IIIF image standard API, which needs to be able to address hierarchical subregions and variants. And this is connected to the next case study. This is for the French National Library, whose NAN again is 12148. So in this example, this is a IIIF compliant URL that requests the return from page 29, at the F29 you see, of a specific rectangular region. Out at the end, you can see the request specifying full quality and the JPEG format. ARCs are flexible. You can throw them away, which is much easier if you have never told anyone about them. ARC metadata is uniquely flexible. For example, starting in the planning phase when it just needs an identifier so you can talk about it. After all, we name our children before they're born. We name our objects before they're born. Then at the moment of birth, when we have a digital object, we might assign a redirection target as the one and only piece of metadata. Later, we might add draft metadata, have it reviewed by others, released and edited again, etc. Persistence is not on or off. Whoops. It is nuanced. Ironically, preservation often involves change. Valuable objects tend to be complex, human-curated clusters of digital artifacts that curators are forced to change in order to keep up with changing technical, policy, security, and legal requirements, as well as user expectations. An ARC should lead to three things: to the identified thing, whether it's digital, physical, or conceptual, to metadata about it, and to a nuanced persistence statement that sets expectations. Here's an example showing an ARC metadata request, which is created by appending a query string consisting of $info appended to it. The last line says that persistence information is unavailable for this particular record. Suffix pass-through is a feature that a web server can choose to support in order to greatly increase the number of identifiers that it can forward. It dramatically reduces the burden of maintaining identifiers by permitting one identifier to stand in for millions. The way it works, given a URL for the stored identifier, if an ARC arrives with an appended suffix, NTT will reappend it, pass it through to the destination during resolution. This is critical for IIIF applications since the many addressable subparts and formats don't all have to be separately registered, maintained, and possibly paid for. This final case study is a visualization from Dave Glace of the U.S. National Science Foundation iSamples project. It allows us to visit the South Pacific island of Moorea in French Polynesia. Each of the colored points represents a physical sample, and the towers indicate that many samples were collected at the same location. Each sample point has an ARC identifier, which is displayed when mousing over it. Clicking on one of the points brings up summary metadata, which allows you to link back to the original collection. Following that link to the Smithsonian, you can find more details about the specimen with cross-references to analyses, publications, and other material. The interlinking is done with millions of ARCs, and the number of participating collections should grow significantly as the project continues. It's all part of the NSF iSamples project, which assigns identifiers to biological specimens, rocks, and archaeological artifacts.
Thank you, John. Any questions? I have one question. Do you? Yeah, please.
I guess, sorry, hi, I'm Owen here. I had a question about, actually I don't know if you can hear me, I'll have to type it after I say it. If ARCs could be withdrawn or edited or changed, would there be like a history or a revision history to ARCs?
Well, ARCs are not centrally managed. I don't know if you can hear me. I hope you can. There's some delay. So they're not centrally managed. Therefore, it's not a property of the ARC scheme. That's a property of a particular implementation.
Yeah, my question was about the persistence information that is added. What exactly could that? Because in the example you showed, it was or there was no persistence information. What could this be?
Yes, there's a longer version of this presentation, which gets into quite a bit of sort of proposed terminology. The persistence statements are not finalized, but a great deal of vocabulary has been set up around things like content variance. That's the
Marcos is asking if you could use hashes as PIDs.
Yes, you can use hashes as PIDs. They have there's a very popular approach to preservation, which suggests that these frozen bit streams, these are bit streams that never change, can be very usefully identified with content hashes. But the problem with that is that they some of these bit streams will gradually become less and less relevant as the content changes, and that is gone into in this larger presentation. I'm going to stop there because I'm hearing my answer with about 10 seconds delay, and I can't quite compete with it. I'll stop.
Yeah, well, thanks to John.
Okay, thank you, everybody. That's it for today, for day one. Thank you so much again to all of you, everybody at home. Thank you for our volunteers for this afternoon. So Zsuzsa, Janneke, Margot, Erwin, and Jacob, thank you so much for your help. And for tonight, as I said earlier, everybody is invited, everybody can come. It's an honor system. So our generous sponsor is sponsoring the food, and it's 2 drinks per person. Okay, 2. So, okay. So, yes, so that's how much is covered. It's 2 drinks per person. So after that, everybody has to pay their own way. So again, just be nice to your neighbor. Don't drink 5 drinks. If you don't, Okay, thank you so much, and we'll see you tomorrow, 9:30 here. Yeah, hope to see you all at the dinner. Thank you so much. Thank you to all of you for coming, participating, and all the presenters and all the contributors. Thank you so much. So 6:15 outside, and the parade will walk to the restaurant.